I'm Tim. This PCBSYNC.
Today, we're not going to talk about theory. We'll jump straight into KiCad. We'll start from scratch and draw a real 50 ohm RF trace. We'll go through the whole process, from setting up the rules to routing and finally checking everything. We'll use our old demo board to draw a transmission line. First, we need to click on board setup. Then we need to go into physical settings to confirm. For the board layers, first we select a 2-layer board, and for the material, we choose FR4. As for the thickness, it's 1.6. The dielectric constant is 4.2, so let's remember this value because both the board thickness and the dielectric constant will affect the trace width. Once we've noted this value, the next step is to go to Tools. Click on Calculator. Then we'll use it to calculate the trace width. First, we need to set up the microstrip here. Dielectric constant. Then for the thickness, it's 1.6, and the copper thickness is 35 microns. After setting these key parameters, there's also the final target value of 50 ohms. Then we calculate the result. We get a value of 3.13. That's the trace width, so now we know the width we need to draw is 3.13. This trace width shouldn't be changed arbitrarily. Since the tool has already provided it, we can just draw it directly. Also, we shouldn't manually change the trace width every time, as that's prone to mistakes. We can set up a net class to control this trace width. Again, open up the board settings, and here you'll find net classes. There's a default one here, but let's add a new net class called RF-5100O. So what next? The most important thing is this trace width, the 3.13 we just calculated. As for the other settings, you can just use the default values, so I won't fill those in for now. After setting up the net class, how do you make it take effect? There's another crucial step. You need to add your target net here. So for this 50 ohm net, I'll give it a name. Let's call it RF1. Then you need to select this net class and change it to the one we just set up. Only then will it take effect. After that, click OK, and the net class will be applied. Now, let's take a look at connecting the RF trace between these two terminals. We select the line tool and start drawing. Oh, here's a problem we've run into. Right now, the default is set to 90 degrees. We need to change that. Even though 90-degree angles aren't the biggest issue for RF anymore, it's still good practice not to draw 90-degree traces. Use 45 degrees or arcs instead. If our frequency isn't high, 45 degrees is actually sufficient. You'll also notice that when we draw this trace, it's quite thick, so let's check if its width is correct. Is it the 3.13 we just set? Yes, it's the 3.13 we just set. This way, every net will default to using this trace width, and we won't have to set it every time. That makes it less likely to make mistakes. A lot of beginners just focus on drawing traces. But what you really need to pay attention to is that there should be a complete reference plane underneath the entire RF trace, so we still need to draw one, a ground plane, and assign it to a certain layer. We need to choose the bottom layer. Then, set the net to GND, then click Confirm. And that's it for this part. Is the ground plane drawn? If you don't have a complete reference plane for the return ground, then no matter how accurately you calculate that 50 ohms, it's useless. Finally, let's run a DRC check. Let's see if there are any errors. Run it once. It passed completely without any issues. And you can also see that the reference plane, the blue area, is complete and not split up. So only at this point can we say that a 50 ohm trace is truly finished. Thanks for watching.